Hello. Welcome back to the channel. So let's do one more question on solving indefinite integral using integration by parts. And in this question, we'll use the substitution approach and also the approach of solving an indefinite integral by using the integration by parts formula multiple times in order to solve our indefinite integrals in these cases. So before watching this video, I'll highly suggest you to first watch my previous videos in order to get the full context of what we will be doing in this video. So I would suggest you to watch the substitution videos and also the videos related to integration by parts formula as well. So in this case, in this question, we'll have to calculate the integral for root s times e to the power root s. So when we look at this question, the first thing that we see is the repetition of root s in this case, right? So that gives us an idea that if we can somehow assume a root s function to be a simpler function, for example x in this case, it will simplify our expression over here, right? Because if we have something like x e to the power x with an additional factor, we can simply use integration by parts in order to solve this indefinite integral over here, right? So that is the basic idea which helps us lean towards using the substitution approach in order to solve or simplify this integral before using the integration by parts formula. You can also use the integration by parts formula straight away, but you'll notice that if you'll use the integration by parts formula straight away in this case, you will overcomplicate this indefinite integral over here. So again, as we discussed, let's assume a new function, for example x in this case, to be root s over here, right? And now since we are using substitution, we know that we have to also substitute or change ds with a dx term over here, right? Because if we are changing our root s expressions to x expressions, we also want to change ds to dx over here. So let's calculate dx in this case. So now if we take the derivative of both sides with respect to s, this would be this one, and the derivative of root s would be 1 by 2 root s, right? This is what we know about derivatives of a square root function. So if I take the derivative of root s with respect to s, it would simply be 1 by 2 root s in this case. And now if we want to calculate dx in this case, our dx would simply be 1 upon 2 root s times ds in this case, right? But since we are substituting ds in this case, let's do the opposite thing. Let's calculate ds over here. So ds would be 2 root s dx in this case, right? So now since we are changing our ds in terms of dx, we have calculated the expression for ds, and we also know that since we assumed our root s function to be x, we can also write this ds as simply 2x dx over here, right? Because we assumed our root s function to be x in this case. So now we can simply convert this ds into 2x dx over here, right? And every occurrence of root s to x as well. So now let's first write the original expression over here. So you have to calculate the integral of root s times e to the power root s ds in this case. And now since we assumed our root s to be simply x, we'll write this as root s will be changed to x, e to the power root s will be changed to e to the power x, ds will be changed to 2x dx in this case, right? And now if we simplify this expression over here, if we write it in terms of something we are already familiar with, it would simply be 2x square e to the power x dx over here, right? And this can be indeed changed to 2 times integral x square e to the power x dx in this case. So now we know that we can easily solve this indefinite integral because we know the integration by parts formula. So we'll assume, just as in the previous video we did a similar problem like this, we'll assume our first function to be x square and the second function to be e to the power x, and we'll see that once we use this assumption of a first function to be this one and the second function to be this one, we will get an integral x e to the power x term, and once we get that term, we'll again use integration by parts formula on integral x e to the power x dx, and then after doing that for the second time we'll get our final answer in this case. We can also try solving this expression over here. So again in this case you have to assume your first function to be x square, which is your polynomial function, the second function to be your exponential function in this type of questions, Again, I would highly suggest you to first watch my previous video where we did a similar problem like this, so that you can get a very good idea about why we assumed our choice of functions to be like this and not the opposite case in this one. And you can always find the video on the I button above. So now let's solve this expression based on the assumptions. We'll simply use the formula. So it would be 2 times first function as it is, integration of second minus differentiation of first, which is 2x, integration of second, and then integration of this whole expression over here, right? And again, in order to solve this, we'll use the integration by parts formula again. So now this expression would be 2 times x square e to the power x minus twice of first function as it is. In this case, again, the first function would be x, the second function would be e to the power x in this case. I'm going over this quickly because we have already solved a similar type of question in the last video. So that is why I'm going over it quickly, because we already know how to solve this type of question from the last video. So this would be first function again as it is, second function integration minus differentiation of first, which is the derivative of x, which is 1, integration of second dx, and then once we'll get rid of all the integral expressions, we'll add the constant of integration at the last. So this would simply be 2 times x square e to the power x minus twice of x e to the power x minus e to the power x over here. And now, since we have got rid of all those indefinite integrals over here, in this expression, we'll add the constant of integration at the last. So now let's simplify this expression again. We'll get 2 times x square e to the power x minus 2x e to the power x plus 2 e to the power x with a constant of integration. Now if you want to calculate the final answer, it would be 2x square e to the power x minus 4x e to the power x plus 4 e to the power x plus c. So this would be your final answer, but in terms of x in this case. You remember the final expression was to calculate the integral of root s e to the power root s ds. So that is why we'll have to convert every occurrence of x with the original function that we changed from, right? So that is why in the final answer, we cannot have x in this case. We'll have to change every occurrence of x to root s in this case. So let's do that. So the final answer, the final answer would be 2 times root s whole square e to the power root s minus 4 root s e to the power root s plus 4 e to the power root s plus the constant of integration in this case. So if you want to tweak it a little bit and solve it further, simplify it further, you would get 2s e to the power root s minus 4 root s e to the power root s plus 4 e to the power root s plus the constant of integration. And now this would be your final answer to the integral, which was originally in terms of s, for the integral root s times e to the power root s ds in this case. So that's it for this video. Again, the main takeaway from this video is whenever you have complex indefinite integrals like this one, and you somehow get an idea that you can use substitution in order to simplify your indefinite integrals, feel free to go ahead with the substitution approach and then see what your final integral would look like. And if the final integral that you form using substitution makes your problem even more simpler, feel free to go ahead with solving your simplified integral based on the function conversions. But also keep one thing in mind, that whenever you get the final answer, make sure you convert every occurrence of your new function and change it back to your original function in these type of questions in this case in order to get the final answer, right? So feel free to comment down in this video if you have any doubts related to this video or any specific concept that we talked about in this video. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.